I'm doing two and three.
Yeah, you're good.
Okay. So we have here on the board question number 1. So part A, we had to figure out what the Q was. So we did the 1 divided by 150,000. Then you do the square root of that to get Q. And then you square that number to get Q squared. And so these are our numbers for that, A and B. And so these are them converted into percentages. And then C, this is the math we worked out for C. It's just P squared. So you just take that number and square it, and you get that. And then for D, since it's heterozygous, you do the 2 times P times Q, and then that's the percentage we got. And then for question number 2,
yeah, do a screen share real quick. Yeah, green button right there. Yep. Just click it. Just click it. And then yeah, share. And boom.
Okay, so for number 2, fill in the blank. We went through our notes and the PowerPoints to get all of these answers. Pretty straightforward, nothing too surprising there. So yeah, we just filled those out.
And then we'll get set for question 3. Pretty good for question 3.
Yeah.
You want me to go over it?
Oh, do you want me to?
It doesn't matter.
So question 3, we did kind of the same thing where you do 1 divided by 6,000 and get the square root of that to get Q. And then you minus this 1 minus this number to get P. And that was both A and B. And then C, you do the 2 times P times Q, get that. And then D, you just plug this in, times it by the 5 million to get 127,400 people affected by that disease that was talked about.
Okay.
Number 4 is a long one.
This is number 4. So number 4, it's asking determine the allele frequencies for R squared and R cubed, basically. So this is what you do here, step by step. You just plug in the observed count, and then to plus it from the 44, because there's the 2 in each one here. So you plus those in there, divided by 380, which is the total allele count. That gives you this decimal here, which is P. Same thing for this one. Then you get that decimal for Q. Moving on to B, it asks for the chi-square test to determine the population and whether it is a good value or not. So this is where you plug in these decimals that you got up here, times it by the total count from these, and then you get your expected counts down here. Plug it into the chi-squared, and then we get these values over here, which comes out to 7.146. So it is a 90% chance, or 90% confident it will fail to reject our null hypothesis.
Perfect. You wanna grab that over here? Then we gotta do number 5. Can I hold this, Chris?
Oh, yeah.
On number 5, since there's no table over here. Yeah, that'll decipher. All right. So for number 5, it's for the first part of number 5. It's asking for the frequency of the genotypes, and so I wrote down what the information that was given to us, and then what it wants us to find. And so when it's a double, you just do that times square it and square it. But when it wants for each one, you just do the 2PQ on there. And then for B, it's just asking for the population of dogs that would have a pale gray phenotype, and that phenotype is heterozygous, which is this same number, and you just times that by the population to get the 150 or 150 dogs. And it's the same process for C and D, just with different phenotypes and genotypes, and whether it's heterozygous or not. And then these are our numbers for those.